We're going to begin covering the individual gas laws, beginning with Mr. Boyle. This is a picture of Mr. Boyle and his lovely hair, or wig, that he has on there. He looked at the relationship between pressure and volume, holding everything else constant. And what he found is that pressure and volume are inversely proportional. So as one goes up, the other goes down, and vice versa. Which you know from math, that's the relationship, this inversely proportional relationship in this example. And here's a table showing that. Notice that our pressure times volume, or our K in this example, are relatively constant. And you see that with this relationship here. In order to keep that constant, we have the volume increasing by 10 milliliters each time. And as the volume increased, the pressure decreased. And we see that relationship here on the graph as well. The pressure and volume are inversely related, and remember that we keep them at a constant temperature and a constant mass. We don't change the amount of gas. So here we have another view of it. If you can imagine this being a case of putting pressure on top of a certain volume of gas. If I were to increase the pressure, that increasing or doubling the pressure is going to reduce the volume in half. If I were to put 3 times the amount of pressure, it would reduce it to 1/3 of its original volume because they are inversely related. So let's take a look at how to do a problem. A gas occupies 100 milliliters at 150 kPa. Find its volume at 200 kPa. We are starting with a gas, and it's the same gas in this situation with 100 milliliters at 150 kPa as it is at 200 kPa. So what we have to look at is keeping the temperature constant and the number of moles constant. Those two things don't come into play, just the pressure and the volume. The first thing we need to look at is what we are given. So in the first instance, or the first scenario, there's 100 milliliters at 150 kPa. We want to know what the volume would be if the pressure were increased to 200 kPa. This is Boyle's law. We have pressure and volume. So as pressure goes up, volume should go down. So before you even start the problem, it's a good idea to look at it and say, okay, what am I looking at here? Do I expect the volume to go up or down? Well, if pressure increased, we expect the volume to decrease. So that should be reflected in the answer that we get. This is the way we use Boyle's law. We set them equal to each other because they are the same gas at the same number of moles and the same temperature, so I can set them equal to each other. So we insert the information that we have, and we solve for what we don't have, which is the second volume. So once you do the easy math, we find out that the second volume is 75 milliliters. You need to ask yourself, is that a reasonable answer? We went from 150 kPa to 200, so we've increased the pressure. We should have decreased the volume, and we did. We went from 100 to 75 milliliters. Each of the problems that you're going to have to work are going to involve something like this with Boyle's law. One of the things I want you to keep in mind is that it doesn't matter what your units are as long as you're consistent. So this first pressure was given in kPas and the second pressure was given in kPas. There's no need to change it to any other unit for pressure. However, if this was given in kPas and my second one was given in atmospheres, you would have to do a conversion to make sure you're on the same playing field and there's same units on both sides. So you would have to do a conversion in that case. This doesn't have to be liters. It can be milliliters. That's fine. It's just that you need to make sure that you're consistent with both sides of the equation, which makes sense because if you can't cancel out the units, then you've done something wrong, which is not setting the units up right. So this is our final answer, the 75 milliliters. And while the math is not difficult in this case, it's very important that you set your work up the way that it's shown set up here. Again, we have issues when you don't write down what you have, what your knowns are and what your unknowns are, and there's not consistency here. We tend to see wrong answers over here. And this is the first of the laws that we're going to cover in this chapter. The math, like I said, is not difficult. The process is not difficult, but you need to show your work in every circumstance because if you have no work, you have no credit. Part of showing your work is writing this out for the first part. So good luck and have fun working with your lab partner.